Good morning, ma'am. My name is Harshita Narula and my student ID is 77367803. First of all, I would like to thanks to my supervisor who support me in my dissertation. My topic for my dissertation is predictive modeling for road traffic accident prevention and AI based approach for Addis Ababa. So let's start with the introduction first. Addis Ababa urban expansion has led to surge in road traffic accidents impacting safety and mobility. The traditional road safety measures have proven insufficient in addressing rising accident rate. Artificial intelligence offers potential solutions through predictive accident modeling. Machine learning help analyze factors influencing accident severity for better prevention strategies. AI powered traffic management system can support evidence based policy making. Addis Ababa urgently needs data driven tools to reduce the traffic fatalities and economic losses. Predictive models can detect high risk patterns related to driver behavior, weather, and the road conditions. Let's discuss the aim of this project. So, the main investigation of this project is to design an AI based predictive system for assessing road traffic accident severity in Addis Ababa. By analyzing driver demographics, environmental conditions, the road infrastructure, the models seek to identify key risk factors and generate proactive safety recommendations. It's also aimed to develop and compare machine learning models such as decision tree, random forest, and neural network to determine the most accurate algorithm for predicting accident severity. The objective of this project is there are four objectives. First is examine the influence of driver demographic characteristics such as like age, gender, education, driver experience. Second objective is to assess the impact of environmental and infrastructure factors including weather condition, the road type, the junction structures and lighting on accident occurrence. The third objective is the predictive models development process using decision tree, the random forest, the neural network should be implemented to achieve effective accident severity classification. The last objective of this is to evaluate the performance of different machine learning models to determine the most effective algorithm for predictive accuracy. Let's discuss the literature gap of this project. So, the most AI based accident prediction models are developed using dataset from developed countries, making them poorly suited for cities like Addis Ababa with unique traffic patterns and infrastructure challenges. Although many models show high prediction accuracy, their practical use is limited due to the complexity, scalability, and integration difficulties with real-time traffic system. Many AI models has lacked transparency, making it difficulty for policymakers and the stakeholders to understand and rely on AI driver decision for traffic safety measures. Existing studies often use imbalanced dataset and fail to integrate diverse real-time data sources like condition of road, weather condition, the behavior of driver due to the effectiveness in dynamic traffic environment. As a result of the literature gap, there is a need for research that bridges these gaps by developing interpretive, scalability, and locally adaptive AI based prediction framework for prediction of accident in high cities like Addis Ababa. Let's discuss the methodology. There are six methodology in this. First is data collection and description. The data was collecting from Addis Ababa Transport Authority covering road traffic accident over the past 5 years. The dataset includes features such as the date, time, location, the type of vehicles, the weather condition. Data exploration was conducted to understand the class distribution and identify missing and inconsistent entries. Pre-processing and feature learning handled missing value through imputations and removed duplicates. Critical features were encoded using one-hot encoding or label encoding. Date and time were converted into spherical feature. Target variable was converted into numerical class for classification tasks. The third is addressing class imbalance with smooth. The dataset shows an imbalance in extensivity categories. Smooth were used to generate synthetic example for minority class. Post-smooth, the class distribution was re-evaluated to ensure balanced learning. Fourth is model development. Multiple machine learning models were developed to predict accident severity and frequency. There are four types of models: logistic regression, random forest, gradient boosting, artificial neural network. Logistic regression as a baseline model. Random forest and the gradient boosting are for tree-based ensemble learning. Artificial neural network for deep pattern recognition in complex data structure. Hyperparameter tuning was conducted using grid search and cross-validation. The fifth is model evaluation. Models were evaluated using performance metrics like accuracy, precision, F1 score, recall. Confusion metrics were used to visualize true positive, false positive. The cross-validation was employed to test model robustness and prevent overfitting. Variable importance and interpretation. Feature importance was analyzed for each model to identify critical extent prediction. Shape value was used to interrupt ANN prediction. Insights from feature analysis were used to suggest the target invention strategies for accident prevention in Addis Ababa. Let's discuss this by exploratory data analysis. So these are the code for these bar graphs, the pie charts. The distribution of accident severity, we use the bar chart and the pie chart to visualize it. Let's discuss the pie chart first. For the composition of accident severity, for high severity 2, it accounts for 84.56. For moderate severity 1, it represents 14.15%, and for the low severity 0, it contributes only 1.28%. Let's discuss the bar graph, the age band of the driver by involved in the accident. So the age of the driver 18 to 30 are mostly involved in the accident, and the age is 31 to 50 are closely behind to it. And the drivers under 18 over 51 has less chance of accident due to the lesser experience of driving. The second is education level of drivers to involve the accident in across the distribution number of drivers across, like for the education level. For the junior high school has mostly accident occur. The drivers who have above high school and the elementary school and the high school are closely behind to it, and the drivers who are illiterate and the writing and the reading skills are lesser accident involves. Accident by the junction type. So at the no junction there are mostly frequently accident occurs. The combination of the Y shape and the crossing has a mostly number of accident counts due to a complex design of it. And the same for the accident by the driver age band. There is a more severity, moderate severity, high severity, and the low severity. The next is accident by the weather condition. The most accident occurs under the normal condition because of the driver behavior has been significantly caused, and the raining and the windy condition has slightly lower accident occurs. Let's discuss the comparison of model. As I discussed, there are four types of a model. So the strength of the logistic regression is simple and efficient. but the weakness is struggle with the non-linear data. Random forest, it handles a missing value, but it is computationally expensive. Gradient boosting, it's handle the complex interaction, but it has lower training. XGBoost is optimized for speed but is sensitive to tuning. Artificial neural network is capture the J patterns, but it requires a large data sets. The hyperparameter tuning using grid search CV. The hyperparameter performance was performed using grid search TV to optimize for the model configuration. For each algorithm like logistic regression, random forest, gradient boosting, and the XG boost, it evaluate the value for the hyperparameter value, and it tested the systematically tested for the maximize the model performance and the cross validation. Artificial neural network, it's a class of machine learning that interrupts using the function of the human brain or the structure. It has three layers. The first is input layer. It receives the raw data. Second is hidden layer. In this layer, it's using the activation function, and the output layers give you the final prediction. It discusses with the graphs like epochs increases, so the loss is reduced and the accuracy is increased. Comparison of model performance. With the table of this, it shows that XGBoost has a best performance in the validation accuracy. With this, the artificial neural network has a lower performance due to the large gap of the training accuracy and the validation accuracy, and due to this it suffers an overfitting severity. These are the four best parameters for the different models, like what are the best parameter for logistic, for gradient, for random forest, for XGBoost. It gives you the best parameter, the accuracy, precision, recall, F1 score, and the support for each models. Now I would like to conclude my project. Tuned XGBoost reveals the best performance and consistency. It offers strong accuracy generalization, especially for severity level 2, due to effective regularization and hyperparameter tuning. Artificial neural network suffered from serve overfitting, highlights a need for structural enhancement and more balanced dataset for effective deep learning. One of the most challenging in all of these models is class imbalance. Its impact model performance under predicting severity level 0 and 1. Smart help but not sufficient alone. Hyperparameter tuning was critical. While it improved some models like XGBoost, it also led to overfitting in others, such as gradient boosting, stressing the needs for careful validation. Future improvements should include cost-sensitive learning, class weighting, and interpretability tools to enhance reliability and policy relevance. These are the references I followed in my dissertation. Let's have a quick look on my data. So this is my data set. Now I would like to show my code as well. So here is my code for my dissertation. These are the graphs, all of it, and the pre-processing and the confusion matrix, the graphs as well. Thank you so much.